All right, section 3.1, Numeration Systems. We had one more example to do in this section. And we were in the process of converting our numbers, our base 10 numbers, into other bases. And the example that we are going to do is to take the number 9999, there's 5 nines there, a bunch of nines. So 99,999, and turn it into base 9. Okay? So what we did last time, I'll just flip back to this other slide. What we did last time is we wrote out the powers of the base we were in, because that's what's going to be the numbers that we're going to be dividing by. So we're going to write out powers of base 9. So 1 would be the first one, always starting with 1. And then the base itself, 9, would be the next one. And then I need 9 squared. What comes? 81. And then I would need 9 cubed, 729. Okay, how about, did you already write these down? 6,000, what was it?
I think it's 6,561.
That's what I have written down as well. What's one more?
I didn't.
Okay, we need one more.
Sorry.
It's okay.
59,049.
And while technically we could do one bigger to see that it really is too big, you're probably looking at this, no, this is already big enough. Because this is 59,000 and our number's 99,000. It's only going to go in there one time. So these are the powers of 9 that we will need to use in our division algorithm. All right, so we write down this sort of division bar graph chart. I don't even know what you want to call it. Scaffolding, I think is what I've called it once before. I like that term. We write the 99,999 underneath the scaffold. And we write the number we're dividing by on the outside, so that's the 59,049. And I already said they answered this. It goes in one time. So 59,049. What do you get if you subtract those? $40,950. All right, and then we're going to go just down the chart. We're going to do the next power of 9 that's below. That's the 6,561. How many whole times will 6,561 go into 40,950? 6? All right. And then I need to know what 6 times 6,561 is.
39,366.
Very good. All right, let's subtract. Does 1584 look okay? Do you guys have calculators today? Nobody's talking to me. Are y'all okay? Yeah? Okay. All right, what are we going to divide by next? 729, exactly. So you might be able to do this one just looking at it. How many times is 729 going to go into this? Twice, yeah. Now, and what is 2 times 729? Yep, 1458 is correct. What do I get if I subtract that one? 126 is dwindling down, right? What am I going to divide 126 by? 81, and it will go in one time. So if I subtract 126 minus 81, what do I get? How much? 45, right? 45 divides by 9, and then 9 goes into 45 5 times. And it's awfully tempting right here to say I'm done, because I've got a remainder of 0, but you need to divide by the last number, 1. Obviously, it doesn't go into 0 any times, but that last 0 is a placeholder, just like zeros are in our place value system. So your solution is 162150. What am I missing? The subscript that says 9 for the base that I'm in, base 9. All right, so I want to show you something interesting based on the last 4 examples that we did. Okay, the ones where we turned them into our base, and then the ones where we turned them out of our base into something else. Take a look and see if you can compare. And conjecture is a word that you see used in this textbook a lot. Conjecture the relationship between a lower base and a higher base. So this is our base 10 number, right? Over here, this is our base 10 number at the top, and then we've got our solution here at the bottom. Over on the 2 before that, here is the base 2 number compared to our base 10 number. And then here's the base 12 number compared to our base 10 number. That probably is not the most helpful example of this because it feels a little awkward to us with the numbers. But can you sort of give an idea of what it looks like is happening when you compare those numbers? Yeah, so when you have the same number, the same value, but in two different bases, if it's a bigger base, the number looks smaller. Either it has fewer digits or it has smaller digits, if that's the case. So like this one, I have a 5-digit number in base 10, but it's a 7-digit number in base 4, right? There's nothing special about that except that it's one of those things that at the end of a problem, if you've done it wrong and you're sort of aware of the fact that I turned it into a bigger base, I should have a smaller number of digits, and it isn't, then maybe you did it backwards. So I want you to write this down at the very end above your homework on the bottom here. Here's the key that you need to remember. You need to remember that when you're going from base something else into base 10, you multiply. Okay, so base 6 into base 10, base 12 into base 10, base 20 into base 10. It's all about multiplication. And when you go from base 10 into some other base, it's always division, the division scaffolding. Every time I give the test that you're going to take at the time, whenever it is we take this test, it's still a little ways away, I always have at least 1 or 2 people that do it backwards. They didn't keep straight which way was which, okay? All right, any questions? All right.